Hello, today we're going to be working on recognizing complex roots and writing equations in standard and factored forms that have complex roots. So this one's probably going to be a little bit longer because I am not going to be in class for this day, and so I'm just basically going to do what I'm going to leave with the sub. So first off, start on the warm-up. Pause it and do the warm-up for yourself. 3i plus 4i, that's going to give us, 7i. 3i times 4i is going to be 12i squared. What we learned last time was that I squared is -1, so this is going to be -12. 2i squared times I, I'm going to go ahead and replace this I squared with the -1, and then this is going to be times 4 times I, so that's going to give me 2 times -1 times 4 will give me -8, and then I. 2i plus 1 plus I plus 5, I'm just going to take the 2i plus 1i, and that's going to give me 3i, and then 1 plus 5 is plus 6. And then subtracting 2i plus 1, I'm going to distribute that, minus I minus 5. 2i minus I is just I, and then 1 minus 5 is -4. So, like we talked about last time, we're going to treat I as a variable, unless we start squaring it or putting it to multiple powers. Not as a variable, let me rephrase that, as we would a variable, unless we square or put to other powers. So the other thing we learned is that I is the square root of -1. Some of you already have this written down, so if you don't worry about it. Or if you do, don't worry about it. And then if you don't, get it on your stamp sheet. And then we also know that I squared is -1. So those are the kind of the 3 big things we learned last time. We also talked about rationalizing the denominator, but I can't figure out a quick note to put on that one, so I'm not gonna. All right. So you guys are going to be working on an investigation today. So what I expect is that you will go through that investigation on your own for a while, and then the sub can play this part for you a little bit later. But for now, I want you to work on your own. So pause it here. So if we are looking at 2 different equations, these are both 3rd degree polynomials, so we know that much about them. So this is a 3rd degree, which means we're going to have 3 roots. Now, in one case, we have 3 real roots, places they actually cross the axis. So we've got 3 x-intercepts. But on the second one, we only have 1 real root. It only crosses the x-axis in 1 place. But we can tell because of this shape that it's got to have that higher degree. So this is going to tell us that this has 2 non-real roots. So we'll keep going from here. The previous one, we knew that we had roots at, hang on, I got to pause and go back. Okay, so we know here we had a real root at 2, and over here we had a real root at x equals 5. So on the previous one, we actually had 3 different roots we could have worked with, but I'm going to go ahead and just work with the one. If I have a real root at x equals 2, then this is going to be x minus 2 for my factor. That there. This is all from last unit. 3x squared minus a -2x squared is going to be 5x squared. -6x minus a -10x is going to give me 4x. And then 4 times -2 is -8. Then I'm going to take x squared plus 5 plus 5x plus 4, and I'm going to factor that. That's going to be x plus 4 times x plus 1. It's my fully factored form, x minus 2 times x plus 4 times x plus 1, which we should really know because this had real roots as well at -4 and -1. That's our fully factored form. This one, if I have a root at x equals 5, this is going to be x minus 5. So this is x squared. Nope, just kidding. It's x to the third. So this is x squared. So negative 5x squared. If I already have a negative 5x squared here, this is going to be 0x squared because I don't need to add anything to it. So that's going to be 0x. I'm going to multiply that to get, again, 0x. And then I need this to be 16x, so this is going to be 16x. Factor out 16. And then I multiply this to get negative 80. So my factored form here is x minus 5 times x squared plus 16. So x squared plus 16, this is a sum of squares, not a difference of squares. So we can't do the x plus 4 times x minus 4. But we know this has imaginary roots, so we can look at it in a couple different ways. One is from the conjugate stuff that we did last unit, or last section. Or we can rewrite this, or we can use the zero product property. So we can do x minus 5 equals 0. So we have a real root at x equals 5. And then over here, we've got x squared plus 16 equals 0. And here we solve, so minus 16. So x squared equals negative 16. Square root both sides, and when we do that, we have to do plus and minus, because whenever we're squaring, square root to solve, we have plus and minus the square root of negative 16. And what we also learned last time was the square root of negative 16 is the same as the the square root of 16 times the times the square root of negative 1. I should just write that out. Square root of 16 times the square root of negative 1, so that gives us 4i. So my answer here, my roots here, are going to be plus and minus 4i. So since I have an a value of 1 up here, I can rewrite this as x minus 5, and my first factor, the x plus 4i, times x minus 4i, and running out of space there. So that's my fully factored form on that one. So, scooch that down. All right. So x-intercepts, those are real roots. Each root has a factor, as we've done before. How do we factor an equation and write it in fully factored form if they're non-real roots? So this we really just did. So I'll go ahead and, no, I don't need to do that again. I can actually just delete this one completely because it's not necessary. Okay, so x squared plus 1. We know how to do that from way back when. This is h of 0 and k of 1. So we take that, move our parabola up 1. So we've got no real roots. So if we look at the factored form, we have to figure out x squared plus 1 equals 0. So subtract 1. X squared equals negative 1. Square root both sides. Remember, that's where you go plus and minus. So x equals the square root. Nope, just kidding. X equals plus and minus I. So our factored form then is x plus I times x minus I. On the next one, y equals negative x squared minus 4. So we go down to negative 4. Because it's negative, it's going to be going down. So this one, again, also does not have any real roots, because we can see it's not crossing that x-axis anywhere. So our factored form is, I'm going to go ahead and take out that -1 so that I have x squared plus 4. And then we take this part and use that conjugate stuff that we've learned. Or we can just, I don't know if I want to, okay, we'll go through the process again. X squared plus 4 equals 0, minus 4, so x squared equals -4. Square root, do the plus or minus. So this is going to be x equals plus or minus 4, nope, not 4, because the square root of 4 is 2, so plus or minus 2i. So our factored form here, y equals x plus 2i and x minus 2i. Okay, so writing the equation of a parabola with complex roots at 7i and -7i, so multiplying these out. So our factored form is going to be x plus 7i, x minus 7i. So we do that over here. X squared, 7ix, -7ix, and then this is going to be -49i squared. Take that over -49, not 14. Sorry about that. -49 times -1 is +49. Our 7ix, positive and negative, add out to 0, so we've got x squared plus 49. All right. So in this reflection part, you can have a lot of different things here. How can you determine if a polynomial will have complex roots from a graph? That one is pretty basic. If you have those little, if it's shaped, you have that parabola shaped, you got that little wiggle somewhere, you know it's going to be more than a first degree, but it's not crossing the x-axis more than once. And then if you determine it from an equation, there's a few ways to go about that as well. You could put it in the quadratic formula and find that you get a square root of a negative number. It could be that it doesn't factor down, or that your roots give you something weird like they did before. But that's more something that I want you to think about, of how you notice that from other things that we did in this. So hopefully you guys went through most of the investigation before you watched the video, but either way, hopefully this makes a little bit of sense to you, and I will see you next time. Bye.